I'm Bérangère Delaby. I'm the lead partners of the Cobracomp project, and today it's the final event of the Cobracomp project. Today marks a significant milestone in our journey toward revolutionizing the composite industry. We have come together as a consortium of partners from different regions and sectors to tackle the challenges and explore the immense potential of braiding technology. Throughout this project, we have worked tirelessly to develop innovative solutions and push the boundaries of what is possible in composite manufacturing. Cobracomp has been a collaborative endeavor, combining the expertises and resources of partners. Together, we have strived to achieve our shared vision of advancing the production processes and materials in the composite sectors. The objectives we set at the beginning of this project were ambitious, and we tried to make significant progress in realizing them. Our journey has been filled with breakthrough, challenges, and countless hours of dedicated research and development. Today, we gather here to celebrate the outcome of our hard work and showcase the impressive results we have achieved. I would like to take a moment to inform you that the entire event is being recorded and will be made available for replay in the coming days. So, if you miss any part of today's presentation or demonstration, rest assured that you will have the opportunity to catch up and relive the experience at your convenience. Before we proceed, I kindly request everyone to be mindful of the microphone settings. Please ensure that your microphones are muted unless you are presenting or actively participating in the discussions. This will help us to maintain a smooth and uninterrupted flow throughout the event. As we navigate through the presentation and demonstration today, you will witness the fruit of our labor. We will see firsthand the advancement in braiding technology, the noble architectures we have developed, and the potential they hold us for various applications. The journey does not end here, and we are looking toward the futures with optimism and determination to further explore and exploit the possibilities that lie ahead. I would like to express my gratitude to the Interreg NWE Europe for their belief in our project and their continued support. I would also like to acknowledge the hard work of the project teams, the researchers, the technicians, and everyone involved in bringing Cobracomp to this stage. Finally, I invite you all to immerse yourself in today's event, to engage in insightful discussions, and to celebrate the achievement of the Cobracomp project. Thank you for all, and let the event begin.
Also, a warm welcome from my side, Kevin Poelmans from AGORIA. I want to give you this brief introduction of how this project started. It all started with a patented novel braiding design made by Georges Cahuzac, which you see down below, which is also, just as the state-of-the-art triaxial braid, is also a triaxial braid, but with a significant advantage of having a possibility to add a lot of UD fibers into the same structure, while also having the possibility to have an interlocked structure, so to avoid the difficulties that can occur due to delamination. What is also nice is that this structure can be made in one shot, so in fact you make two layers in one shot. Braiding overall is a very interesting composite production technology for Europe, because it can be highly automated and it also generates not a lot of waste material.
As I explained in the introduction, Cobracomp project was financed by the NWE Europe program, bringing together 8 partners from 3 regions, France, Belgium, and the Netherlands. The partners of the project was EURAMATERIALS, Onset, Collins Aerospace, CoExpert, the University of Twente, Eurocarbon, Santexbel, and AGORIA. Together, these partners have joined forces to drive innovation and advancement in the composites industry. The main objectives of the Cobracomp project have guided our works from the start. We aim to develop a braiding machine capable of creating a new 3D architectures. Alongside this, we saw the established numerical simulation tools to predict mechanical properties based on the geometry of the braiding. Rigorous mechanical tests were conducted on the braiding reinforcement, enabling us to validate their performance. Moreover, the project entailed the creation of demonstrators showcasing the potential of this specific component. Lastly, we have dedicated ourselves to organizing workshops focused on composite braiding, with the aim of disseminating knowledge and raising awareness about this exciting technology. Throughout the project's duration, the collaboration between our partners has been truly remarkable, and we have leveraged our collective knowledge and expertise to drive innovation and achieve results. Today, we have the privilege of sharing with you the culmination of the efforts. We will present the braiding machine, the advancement in numerical simulations, the mechanical test results, and the sample we have produced. This event serves as an opportunity to showcase the immense potential of braided composites and the transformative impact that they can have on various industries. And now I will present with Kevin all the partners of the project and the work we have done.
The consortium was nicely put together following the principle of the triple helix. So companies from the industry with Ratier Figeac, CoExpert and Eurocarbon, but also including the academia and technology centers represented here by Centexbel, ANSET and University of Twente. And next to this, we have the clusters and the industry federation, EURAMATERIALS and AGORIA. Of course, this project cannot be a success without the help of the associate partners, so we have a good connection with them. Through EUSIA, which is the European Composite Industry Association, Composites NL, the Dutch Composites Cluster, Fidustria, the Belgian Textile and Furniture Federation, Skywin, the Walloon Aerospace Cluster, and then Clubtex, the French Textile Association.
In the consortium, you have EuroMaterials. So EuroMaterials has taken on the responsibility of coordinating and managing the project activities. And the key strength of EuroMaterials was the extensive network and connection with the industry. They have effectively utilized their relationships to the interface with other business supports, organization, and enabling the efficient dissemination of knowledge and information to our target group. Eurocarbon has taken the responsibility of designing and building a pilot-scale machine prototype in close collaboration with ANSET and Centexbel. Working closely, Eurocarbon brings their technical expertise and experience to the table. This collaborative approach ensures that the machine prototype is designed and built to meet the specific requirements and objective of the project.
ANSET, represented here on the picture by Amat, Georges, Quentin, and Xavier, participate highly in the design and the manufacturing of the machine, and also the optimization of the prototypes that were needed to come to a working machine. Next to this, they focused on the sample characterization of the dry textile braids, but also from the composite materials, composites that are reinforced with these braids. Above that, they looked a lot at the geometry of the new architecture and the state of the art, and took this into the modeling to predict already the performance of the composites after production.
Centexbel in the consortium has been instrumental in advancing the field of braiding composites by utilizing their own multi-layers and multi-axial interlock braiding machine and expertise. They have leveraged their state-of-the-art multi-layers, and which is the key tool in the production of the braiding structures. CoExpert takes charge of the critical task of processing composite parts reinforced with braids, contributing significantly to the project's success. The University of Twente brings their expertise in braiding simulations and extend their work to the novel triaxial architectures technology to be developed within the project. The University of Twente plays a crucial role in bridging the gap between macroscopic prediction and the mesoscale fiber distribution in the composite materials.
The final partners, I have also the nice thing to present myself. Kevin Poelmans working for AGORIA. AGORIA has been the leader of the long-term effect and the dissemination work packages. The dissemination is being done through the network of the AGORIA network, so the Technology Federation, but also the composite sector represented in this Technology Federation, and also the associate partners, which we are a member of. But also we are expected to gather the end user needs and specifications for a successful implementation of the project. Finally, Ratier Figeac is a composite hydrostructure manufacturer who is in close contact with the end user. So they are in the perfect situation to define the use cases for both the materials and the process development, but also give the specifications that are required to make this project a success and this product and process a success. There has been a close collaboration between Coexpert, Eurocarbon, and Ratier Figeac to make the parts, but also not only the parts, but also sub-assembly demonstrators to really have a good idea of what the design can bring.
And finally, we have embarked on 6 distinct work packages, each playing a crucial role in realizing the project goals and objectives. We have the 3 common work packages in each program, like the work package management, communication, and long-term effects. But we have 3 scientific work packages. The first one was dedicated to the development and testing of the innovative braiding process. This work package aimed to put the boundaries of braiding technology and create a new process that enables advanced braided composite with enhanced performance and capabilities. Complementing the work package 1, we have the work package 2, which focused on the validation of the developed technology for the creation of a technology demonstrators. This work package aimed to showcase the practical application of the new braiding process, ensuring the feasibility, functionality, and relevance in a real-world scenarios. Lastly, we have the third work package, which had a crucial role in disseminating the knowledge and outcomes of the Cobracomp project to enterprises. This work package aimed to raise awareness among potential end users, showcasing the capabilities and benefits of the developed technology. By facilitating knowledge transfer and engagement with the industry stakeholders, the Work Package 3 aimed to foster the adoption and implementation of braided composite in various sectors. In the conclusion, the work plan of the Cobracomp project encompassed a comprehensive and a strategic approach to drive innovation, collaboration, and knowledge dissemination. Through the successful execution of this work package, we have made significant strides toward advancing the field of braiding composites and laying the groundwork for the future's application. So I would like to thank you for watching me and Kevin, and I would like to introduce the next presentation, with manufacturing of composite based on composite and their mechanical performance by Xavier Legrand from Anset.